Developers heavily rely on the use of third-party libraries in software development. Most of these libraries are open source, which is another vector through which vulnerabilities or bugs can be introduced into systems. Our research investigates the nature of Python library migrations to help developers with library selection. Software supply chain attacks have been increasing by 300% according to Argonne Security. 70% of organizations that experience software supply chain attacks lack proper policies for using open source libraries. The goal of our study is to raise awareness for choosing third-party Python libraries and to provide insights around library migration in Python. There are still gaps in literature on library migrations when it comes to Python. Most library migration studies focus on Java. The rising popularity of Python presents the need to investigate Python library migration trends. The motivation of our study is to help developers select Python libraries carefully by providing insights around library removal and library migrations in Python projects. We categorize the libraries under different domains and explore the frequency of changes under certain domains. These insights will help developers choose the right library with security, performance, compatibility, and cost in mind. Another motivation that played an important role behind the study was understanding if centralization improves compatibility. Currently, centralization plays an important role in the software development ecosystem, but it also introduces compatibility and security issues.
Our study is based on the paper A Large-Scale Empirical Study on Java Library Migrations by He, Gu, and Zhao. This study analyzes Java GitHub projects in order to determine existing trends in the scale, domain, and reasoning behind Java library migrations, for which we performed a similar study on Python. It was useful for determining our research questions and methodology, which we also pulled from PyMakeBench and PyMakeTax et al. This other paper is one of the few studies done on Python library migrations, and we were specifically interested in PyMakeBench, which is a benchmark of real Python library migrations of 34 unique pairs of libraries. We utilized their summary of library migration pairs to help us expand our own list and categorize our domains, which we used in our dependency analysis to identify the purposes of libraries for each project.
The data was collected from libraries.io focusing on Python projects. We isolated the relevant data from multiple available datasets in a single CSV file for our preliminary analysis. Using Google Colab, we performed our preliminary research where we isolated 300 projects with one or more libraries where each library had at least 10 GitHub stars. For each version of a project, we separated the libraries used in that respective version. We tracked each library in the next versions of the respective project to figure out if it was dropped, migrated, or kept, thus forming a trend. Once we established a trend in library changes, we isolated the domains that go through frequent changes. After a preliminary analysis of 300 projects, which includes one or more dependencies with at least 10 stars, we found the following results. On average, 12% of all the dependencies were removed from the projects. Out of 300 projects, 101 of them removed at least one dependency. Projects that have to remove dependencies on average removed 42% of the total dependencies in their entire software development lifecycle. We categorized the dependencies under certain domains, and we found out that removals mostly occurred in the following domains: cryptography, development frameworks, utilities, HTTP client server, and logging and tracing libraries. We also found out that migrations mostly occurred in the following domains: cryptography, web development frameworks, and utilities. We furthermore researched the reasons behind these migrations, and we found out that one of the most important reasons were security, and as a result which cryptography went through a lot of migrations. Some of the things we learned while performing our analysis was we learned how to manipulate data sets at large CSV sizes. We learned how to do Python processing on those data sets using certain data science methodologies. Security concerns were fairly common from our findings, and particularly important for the libraries that were no longer being maintained. As emerging libraries with more developers behind them popped up, some older ones tend to get replaced. We suspect we suspect that there is significant correlation between libraries' popularity and usability, although we did not realize this further. If it works, don't fix it tends to hold up. Many projects where migrations did not happen still use some of the libraries that other projects migrated away from. It seems that there needs to be a concern around security, maintenance, usability of the dependencies before the effort in migration is spent.
Finally, we have our ethical implications. So, what we are trying to do essentially in this project is use data science to identify popular libraries with the purpose of helping developers choose their modules. The effect that one might expect of this is an acceleration of adoption of the most popular ones to the detriment of others. This brings up concerns that such consolidation will likely occur under the largest developers who have the most funding, leaving the other developers at the whims of those who are in charge of said libraries. This could also lead to other issues, such as box thinking and exposure of the library's users to any common vulnerabilities.